Okay, so this is the solution for example number 2. Okay, so it is given, you are given with this equation, with this value from the question. Okay, sigma x, sigma y, and tau xy. Okay, so first let's find out what is the stress component that acting on plane CD. So let's say this is the plane CD. Okay, so what stresses that involve in plane CD is sigma x prime and tau x prime y prime. Okay, so the angle is negative 30 degrees. So why it is negative? Because it is oriented into clockwise. Okay, so the sign is negative here. Okay, so you can use the stress component along x prime y prime axis equation as in equation number 2 and equation number 1 and equation number 2. You can just straightly use this equation to calculate what is sigma x prime and tau x prime y prime. Okay, so for sigma x prime, so you just need to substitute this value into this equation. Okay, so we have sigma x is equals to negative 80 plus 50 divided by 2, and then plus negative 80 minus positive 50 divided by 2, and multiply with cosine 2 theta. Okay, so this one is cosine 2 theta, so theta you have to substitute with negative 30 degrees, so you get like this, and then plus tau xy, which is negative value, negative 25 sine 2 times negative 30 degree. Okay, so you will get sigma x prime is equals to negative 25.8 megapascal. So what happens if you have negative value here? Okay, since first we assume that sigma x is acting outward, okay, in this direction, but then we got the value negative, so that's mean actually normal stress for x prime is acting inwards. Okay, so that's why we got negative value here. Okay, next is tau x prime y prime. Okay, so the same, you have to substitute all these values, sigma x, sigma y, and also theta, and also tau xy. Okay, so you will get negative 68.8 megapascal. Okay, now let's find what is the value of the normal stress acting on y prime axis. Okay, you can directly use this equation number 3, to find out what is the sigma y prime. Okay, so here if you are using equation number 3, okay, you can just directly use theta is equals to negative 30 degree. Okay, so negative 30 degree, so you have to substitute negative 30 here and here, and then you will get negative 4.15 megapascal for normal stress in y prime axis. Okay, but alternatively, you can also try to find the normal stress in y-axis using equation 1 and equation 2. Okay, equation 1. Okay, so you can try to use this equation number 1. Okay, so let's say now this is plane BC. Okay, so the stress components that acting on plane BC is, now you are assuming that this is your new x prime axis. So this is your old x, this is your new x prime axis, and then this is sigma x prime that you have to determine. Okay, sigma x prime you have to determine. Okay, so now here just substitute the value of sigma x, sigma y, and tau xy, and here theta, for theta, so you have to substitute 60 degree. Okay, why 60 degree? Because the angle from the original x-axis to the new x prime axis, okay, it is like it is rotated anti-clockwise. Okay, anti-clockwise. When it is rotated anti-clockwise, so the sign convention for the angle is positive. Okay, so now this is the angle 60 degree. Okay, so you can substitute 60 degree here and you will get negative 4.15 megapascal, and it is just the same as you calculate sigma y prime using equation 3. Okay, the same value. Okay, and then same for the tau x prime y prime using equation number 2. Okay, you just need to substitute positive 60 degree for the theta, so and then you will get negative 68.8 megapascal.